Today we're going to be talking about topic 3.1, which is the chain rule. And we're going to see how we can do with this. This is one of my favorite topics, and we use it forever. We've actually been using it without knowing it, mostly because we didn't involve any that got complicated. But this is really one of the hearts of calculus, so we need to be sure we're really, really good at this rule. We're actually going to spend a long time on it. All right. Let's go ahead and get to it. So we're going to be talking about chocolate, which is always fun. The process of making chocolate is quite involved and includes multiple steps. In large chocolate factories, this process has many automated components and uses an assembly line. At each station, a single component of the process is completed before it is set off to the next station in the chain. The step for making chocolate bars are jumbled below. Put them in the correct order by numbering them, each step from 1 to 4. Mix in other dry ingredients, packaging, conching and tempering, which means heating and smoothing out the chocolate paste, and roasting and crushing the beans. So these are some ideas. So what I'd like you to do is we're going to call this one A, B, and C, and D. And so we're going to pause the video. You're going to type up your answer for me. You're going to decide which one's which. And so you'll say, like if you went in order, it'd be A1, B2, C3, D4. So that's not the right order. Obviously, we wouldn't put them in order and then say, hey, put them in order. That seems ridiculous. So I want you to think about what you think has to happen fast. When we're talking about beans, we're talking about cocoa beans, in case you didn't know. And see what you can come up with. Good luck. Go ahead and pause. Figure it out. So you'll notice that this is the order that I chose, roasting and crushing the beans, then adding the other dry ingredients, then conching and tempering, and then packaging. I feel like something's missing from this, like maybe we need some wet ingredients at some point before we start tempering. That seems a little strange to me, but it just kind of depends on what the beans come out of, if it's powdery or if it's smooth. But I think, anyway, I don't know. Just this order I chose. All right. So list the inputs and outputs at each step in the chocolate making process. So the very first thing we start with is cocoa beans. So we start with beans. And then out comes roasted and crushed beans. Notice there are 5 outputs. So, and then next, we mix in other ingredients. Yeah, it's spelled badly, so ignore that. Then we conch and temper. And then last we package. So there you go. Bean processing, making process. So there you go. Pretty simple, right? And so if you recall, we've talked about this before, like with inputs and outputs and multiple functions in previous courses where you have to take one thing and make another. And so the chain rule is about most functions, which are functions put together. So let's see what we got. We're going to use this assembly line approach to analyze a complex function like this one. Like how would we take the derivative of y equals sine of x squared minus 3? The raw material as your input or independent variable. What is the independent variable of this function? So in this case, I believe it's x. Imagine evaluating this function at x. What happens first at x equals 5? So I would have this. What do I do first? Well, first I'm going to plug it in, right? And the final step will be, and then we'll get, and then we'll square. I'm just going to write all the steps. All right. So just kind of looking over this again. We're plugging in. First over which we're going to square 5, then subtract 3. from the result. And in the final step, we're going to evaluate sine at, we're going to end up with 25 minus 3, so sine at, the result. I'm just going to say the result. Which in this case is 22. Okay, and so, but what did we really do? So one thing we can look at and think about is we have x, which went into our inside function. Well, actually, let's take a look at this. X is the independent variable, or the raw material, right? And so x goes into a function. So x went into x squared minus 3. And then whatever came out of that went into sine of q, for example. Okay, so this is q. So that's what happened. And if we call this f g of x, we call this f of x. So g of x and f of x. F of g, if you will. Okay, and so it's kind of like that's what's happening. All right, let's go ahead and see what we can do with calculus now, because this isn't calculus. We're talking about other stuff. We're not doing calculus. To find the derivative of this function, we consider how each link in the chain contributes to end products. If black square equals x squared minus 6, what is the derivative of the black square? So d square dx is equal to 2x, right? Plugging back into our original function, we can see that y equals sine of x, sine of square, right? Because that's square. Okay, and so y, dy d square, taking the derivative with respect to square. So normally we take the derivative with respect to x, but since square is what's in our function, we're going to take the derivative with the square. Okay, right? Because we're doing this, and our independent here is this black square. And so we're going to get cosine of square, right? How can we use our products? What can we do? We want to get dy dx, and we have d squared dx and dy d square. So we have d square dx and dy d square, and we want to have dy dx. So what could we do so that would happen? And the answer is multiply, because these would cancel each other out. Notice the air quotes. They would take care of each other, right? And so let's take that with our problem. We'll have cosine of, remember this was square, times 2x. Or if we put it in the other order, let's put it in the other order. dy dx equals 2x times cosine x squared minus 3. Looks better. So there we go. That's it. That's our derivative. Not too bad. So what does this mean? So we're talking about the chain rule today. Composite function. So when you have an inside function and an outside function. So inside function in this case we call square. So y of f of g of x, the chain rule is used for finding derivatives of composite functions. So y equals g prime of g, so the inside, derivative of the inside, times the outside of the inside function, derivative of the outside of the inside function, or this. Go ahead and write this down. We'll talk about it in just a second. So if you didn't already pause it, you should have, because I'm going to start talking over you. So composite functions, inside, outside. And so when I say this, I take the derivative of what I see. So let's say I had y equals 5 times x squared minus 10. Let's make that a little, actually, let's make that much cleaner. I don't like this function I made up. I want it to go away. So instead, let's say we have x squared minus 8x plus 5 quantity cubed. And I want to take the derivative. Well, I need to, I could expand, write it all down, multiply it all out, or, I have some tools, but not always. Like the one we just did with sine, we couldn't have done anything to simplify it. So what we do is really straightforward, and I know it looks a little more complicated, but it's really straightforward. I take the derivative using the power rule of the main function, 3. The stuff inside stays there to the second power, okay? And then I take the derivative of the stuff inside, of my inside stuff, or in this case, 2x minus 8. And that's my derivative. So we can think of like the chain rule being like this. To take the derivative of...
I'm already finished in the shower.
Spencer? Alright, so as I was saying, so let's say I had, let's just do a power rule here really quickly. So I had y equals square to the nth power. So y equals n times square raised to the n minus 1 times the derivative of the square with respect to x. That's all we're doing. They put the derivative in front because it's often nicer to have it there. I usually tack it on the end and then rearrange. It doesn't really matter. All right. So we will continue in the next video. We'll do some check your understanding. We'll see you guys soon.